Hi, today we have 20 minutes to solve this today's daily lead code question. Let's see if I can do that. So, first stage is reading the question and understanding it. So, let's see. You are given two integer arrays, source and target, both of length n. You are also given an array allowed swaps. Okay. Um, where each allowed swap I is A of I, B of I indicate that you are allowed to swap elements at index A of I and B of I of any source. Hmm. Note that you can swap elements at a specific pair of indices multiple times in any order. The Hamming distance of two arrays of the same length, source and target, is the number of positions where the elements are different. Formally, it is the number of indices I for 0 to n minus 1, where source of I is not equal to target of I. Okay, so if I understand this correctly, wherever the the numbers don't match, that is considered as Hamming weight distance. Return the minimum Hamming distance of a source and target after performing any amount of swaps on array source. So we have to find minimum Hamming distance. That means we have to make the array same. I think so. Let's take an example. So, and this is timer running, so I will stop at 20 minutes if I can't solve it. So, yeah, let's take this example 1, 2, 3, 4 and target 2, 1, 4, 5. Allowed swaps are 0, 1 and 2, 3. And we can swap only in source. Swap 0, 1, so 2, 1. Swap 2, 3, 4, 3. The Hamming distance of source and target is 1 as there is differ in one position index 3. Okay, makes sense. We don't have any allowed swaps, so wherever it differs, that's the Hamming distance, which is 2. In this case, we can make array equal to um, source equal to target, so we can do that. The only thing I need to understand is, can we use the allowed swap multiple times? Note that you can swap elements at a specific pair of indices multiple times and in any order. So if I swap this and then swap this and then I swap this again, I think that's allowed. Okay, I still don't know how to solve this. What are constraints? So we have this is equal, this is fine. The numbers are positive, that's fine. We are in 10 raised to 5 range, that's fine. Allowed swap can be 0, okay. And the length of allowed swap will be 2, and this will be um, yeah, not equal to and in between, so that's good. Okay, makes sense. uh, what can be a brute force approach here? um, So, hmm, can so one thing that's coming to my mind is, can I take an index, let's say for example this, and make it at a position 2, right? So how can I do that? Um, so I need to find if any index. This looks like a graph problem. I don't know. Uh, yeah, I'm gonna struggle with this problem. So I don't think it's gonna be that easy. But let's see. So we know I want to move 5 to second position, and I can swap with second is like one position, right? So I cannot swap it directly, but I can swap it somehow. Let's see how. So I can swap 0 and 4, and then I can swap 4 and 1. Hmm. And then I can swap again 0 and 4. So 1 comes here, 5 comes here, and 3 remains here. Okay. And then for 4 2, I can swap 4 2, and then hmm, okay, still not clear in my mind. Even the brute force is not clear yet. Can I swap this? So, hmm, so 1, 2, 3, 4, 0. So looking at this, there are all indices in here, right? So 0, 1, 2, 3, 4, and this include all of them. So that means I can use this any number of times to move any index to at any place. So in that case, this is easier. Um, the problem occurs where we have less than expected indices. So this is 0, 1, 2, 3. Oh, so that is also not possible because this is 0, 1, and then 2, 3. But there is no connection between 1 and 2. Hmm. Is it? Mm, no, that's. How can I solve this? How can I solve this? There are only two things that comes to my mind. Is one is make a connection of this, like where all I can touch using allowed, um, allowed swaps. So in this case only first two and then second two. um, okay, also there is no value. um, yeah, just notice this and this can also be not same. So this is 1 2 3 4 and this is 1 2 4 5. So you cannot make at least one index same here. um, so if I had this, let's take an example. So if I had 1 2 3 4 and 3 1 2 4 2, right? So what I'm trying to do is, just to be clear, this is like, if you get this in interview and if you have not gotten idea in 10 minutes, you are absolutely failed. There is no way they will pass you. Talking this from an experience. Anyways, so this is the source, this is the target, and I have same allowed swaps, so I can swap only these two and these two. So in this case, even though all the indices, all the characters are exactly same, I can only swap 1 3 and then 2 4, and still will be missing this link of 3 and 2. We cannot swap these two. So the answer will be 2 in this case. Hmm. Okay, okay. So now I can see some pattern here. So I can take this one and see where it's going to go. So this is this, and I will check if I can swap it somehow. In this case, yes. So it will become 2 and 1. Okay. So now I will go here and so this will be 1 already, right? But okay. But then I have to check again the 2, which is here. Where is its correct place in the target? Um, and can I swap it? Not really. Let's see the hint. I think I'm struggling. The source array can be imagined as a graph. Okay, this is what I was thinking. The graph where each index is a node and each allowed swap is an edge. Never in my mind I thought this would be a graph problem. But let's see. What they are saying is this is a graph and these are the edges. Yeah, so something like union find was coming to my mind. Uh, and if I union this, this would look like so 0 to 1, 2 to 3. What does that mean? Does not mean anything right now for me. Okay. Nodes within the same component can be freely swapped with each other. Okay, again, this is coming to union find. So, if parent of any node is same, we can swap them. Here we can swap them. Okay. For each component, find the number of common elements. The elements that are not common will contribute to the total Hamming distance. Okay, what is this? What does this mean? Find the number of common elements. Mm, 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 mm. Okay. Yeah, I'm pretty sure this is something like Union Find crossed my mind, but I didn't go deep into that. As we have only 3 minutes left, let me see what is the solution. Did I haven't solved this before. Um, let's see in Kotlin. This guy is great. You can't understand his solutions, but let's see. Yeah, this is too complicated. We have to go back. Um, okay, let's see this one. Okay, my intuition was at least right. Union find to group indices and for each connected component. Let's see in Python. So we have this is union find, this is find. So groups, and for I in range, find I, append source I. Okay. Okay, this is not making any sense. So this is our main function. Okay. So this is the basic thing. Okay. Yeah, I think this is bad. This is really bad. Yeah, I can't post this. Maybe I will, just to show that how much struggle it is to solve these problems. Uh, but yeah. Sorry guys, cannot solve it today. See you.